Imagine a place far away, far beyond every familiar planet, where sunlight has faded into a single bright speck, only slightly more radiant than the countless stars scattered across a deep, endless black. In that distant realm, there is no blue sky, no white clouds, no whisper of wind or echo of waves. There is only a cold, near-perfect emptiness, a stillness so complete it feels as though the entire universe is quietly holding its breath. The stars aren't pinned to a sky the way we see them from Earth. Instead, they surround you from every direction, turning space into an invisible ocean filled with tiny drifting grains of light. Within this vast picture, the solar system appears like a small island. At its center burns the brilliant sun, holding each planet in orbit with an unseen pull. Closer in are the rocky worlds, including tiny Earth, spinning gently along with its oceans and continents. Farther out drift the giant gas planets, circling in wide, solemn paths like silent guardians. Beyond those distant orbits, the light grows thin, the solar wind weakens, and a boundary begins to form. A delicate threshold between the inner realm shaped by the sun and the outer realm belonging to the space between the stars. Near that fragile frontier, two small travelers, Voyager 1 and Voyager 2, continue their journey that began in 1977. Each spacecraft weighs only about 800 kilograms, carrying a dish-shaped antenna, a handful of scientific instruments, a simple guidance system, and a slowly warming nuclear power source. They host no astronauts, no seats for humans, yet they carry the intelligence and hope of the thousands who built, tested, and entrusted them with their dreams. Over time, the Voyagers have drifted so far that they are now the most distant human-made objects ever sent from Earth, sailing through a region no machine had touched before. Voyager 1 has crossed beyond the bubble of solar wind into what scientists call interstellar space, a place where plasma and cosmic rays bear the signature of an entire galaxy. Voyager 2, after visiting all 4 giant planets, has crossed the same boundary at a different point along the surface of this vast bubble. From Earth, no one can see the 2 spacecraft. They exist only through faint radio murmurs that take many hours to return home. Each tiny packet of data feels like a soft message from the outermost suburbs of our solar system. To picture it more easily, imagine the solar system as an oasis in a cosmic desert. The sun is a fire at the center, blowing out a stream of charged particles that forms a giant bubble called the heliosphere, an invisible, flexible wall encasing all the planets. Inside this bubble, the particles and magnetic fields are shaped mostly by the sun, and cosmic rays from beyond are diminished. Outside the bubble, particles and magnetic fields come from countless other stars, with no single center guiding them. The boundary between these regions is exactly where the Voyagers are quietly drifting and measuring. Their instruments cannot capture a dramatic view of this frontier. Around them lies only darkness and thin plasma, but they measure things the human eye cannot see. They record the fading of low-energy particles from the sun, the rise of high-energy cosmic rays from deeper space, and the way magnetic fields shift in direction and strength. Each time those values jump suddenly, scientists pause to wonder whether a Voyager has moved closer to the true edge of the bubble. Over many years, millions of tiny measurements have assembled the first real portrait of the solar system's outer boundary. From humanity's perspective, the moment these small spacecraft reach the heliosphere's edge is deeply meaningful. From a single world, we sent out explorers that will never return, accepting that they will drift forever in darkness as their energy slowly dwindles. In exchange for a few precious decades, They transformed a vague idea into numbers we can measure, verify, and use to understand the environment our solar system swims through. For the first time, the question, "Where is the edge of the solar system?" is answered with experimental evidence taken from the boundary itself. And so a gentle question emerges. On their long journey, what have these metal wanderers witnessed at the farthest reach of the sun's influence? At the edge of the bubble, where the wind from our star meets the winds of others, the signals Voyager sends back softly whisper the true structure of the space between stars. By following their trail, step by step, the story of what the Voyagers discovered at the edge of the solar system gradually appears, slow, calm, and tender, like the quiet progress of the two spacecraft drifting through the dark. Far, far away. From that quiet edge of the solar system, the story carries us backward in time, back to the moment when the two metal travelers had not yet left the blue world they came from. Everything the Voyagers would one day discover began at a rare moment in history, when humanity first recognized a fleeting chance to open a new cosmic doorway. In 1977, NASA found itself standing before an astronomical opportunity that appears only once every 176 years. The giant planets of the solar system, Jupiter, Saturn, Uranus, and Neptune, had fallen into a special alignment. This arrangement created a natural gravitational corridor through which a spacecraft, if launched at the right moment, could visit each planet in turn without needing much fuel. The gravity of each world could be used as a boost, speeding the spacecraft along and bending its path without expending engine power. NASA called this plan the Grand Tour, a magnificent voyage through distant worlds that humanity had never seen up close. The idea had been nurtured for years before the opportunity arose, but only in 1977 did every condition finally converge to make it real. To seize this once-in-a-lifetime chance, engineers decided to build a pair of nearly identical spacecraft in case one encountered trouble along the way. These would become Voyager 1 and Voyager 2. The two probes were like twin siblings of metal, born of the same ambition and carrying the most advanced scientific instruments humanity could create at the time. Each weighed about 800 kilograms and carried a familiar array: a large parabolic antenna for communication, instruments to measure plasma, sensors for energetic particles, a magnetometer, cameras capable of capturing images of distant worlds, and specialized tools to measure radiation and radio waves in space. Every component was designed to survive a place where temperatures could fall to hundreds of degrees below zero, and cosmic radiation could fry any fragile circuit. Because solar panels were useless so far from the sun, each Voyager carried an RTG nuclear power source, electricity generated by the heat of decaying plutonium. The power it produced was modest, just enough for the essential instruments, but steady and enduring for decades, offering a quiet, continuous heartbeat for the two spacecraft. As engineers at the Jet Propulsion Laboratory looked at the Voyagers before launch, they understood these were more than machines. In their design and careful construction lived the shared hope of sending a piece of humanity's intellect beyond the warm safety of the solar hearth. Launch day arrived, and in a curious twist, Voyager 2 was launched before Voyager 1 on August 20th, 1977. Nearly 3 weeks later, on September 5th, Voyager 1 followed. Both rose from Cape Canaveral, a place that had witnessed so many milestones of the space age. Photographs still preserve the moment each Titan 3E rocket lifted its Voyager skyward, a bright column of flame, blooming against the morning air. Earth trembled softly under the thrust, while each spacecraft slowly escaped its pull. The scene was powerful, Yet what many remember most is not the roar of the engines, but the quiet wonder of watching two small creations become the first emissaries of a journey beyond all boundaries. But the Voyagers carried more than scientific instruments. Each spacecraft also carried a profoundly symbolic object, the Voyager Golden Record. It was a gold-plated copper disc, sealed in a protective aluminum cover and prepared by a team led by Carl Sagan. The record held images of Earth, the laughter of children, the sound of wind sweeping over fields, the crash of ocean waves, the voices of animals, music from many cultures, and greetings in 55 human languages. Among them were English, ancient Greek, Mandarin, Hindi, Arabic, and a rich variety of indigenous languages. Together, they formed a gentle message to any extraterrestrial civilization that might encounter Voyager in the far future. That Earth has life, has art, has emotion, and carries a deep desire to connect. When creating the Golden Record, scientists knew the odds of anyone finding it were extraordinarily small, almost non-existent. Yet they placed their faith in the idea that even a tiny, sincere greeting still held meaning. The universe is unimaginably vast, and Voyager's path is part of that vastness. The record became a whisper sent into the night, carrying the fragile hope that someday, somewhere, someone might hear it. And if they did, they would learn that on a small blue planet lived people who cherished peace, cherished beauty, and longed to understand the cosmos. Seen from this perspective, the Voyagers are not just scientific spacecraft. They are two siblings carrying the story of Earth, a story told in images, sounds, and greetings that reflect the rich diversity of humankind. Engineers often describe the Golden Record as a message in a bottle, released into the cosmic ocean. And truly, if that ocean is endless, then the Voyagers will drift endlessly as well, carrying our story beyond the distance where even sunlight fades. When the two spacecraft left Earth, no one knew exactly what awaited them. They only knew the astronomical alignment would not return within a human lifetime, and that if Voyager was not launched then, the grand tour would be impossible for centuries. That determination forged one of the greatest scientific missions in history. The Voyagers soared upward, growing lighter as Earth's gravity loosened its hold, leaving behind the blue sky, the oceans, the forests, and everything familiar. Ahead of them stretched a long journey through worlds no human had ever seen up close. This beginning feels like the first page of a legendary book where a pair of siblings step into an endless adventure. And from that very departure, the story leads us toward the first moments when the Voyagers left Earth and began to witness the vast universe beyond. Looking back at the earlier chapter about the edge of the solar system, we can see that every later discovery was rooted in those first launches. From this opening page, the story continues, guiding us into the early paths the Voyagers traveled, places that had lived only in our imagination before their arrival. From the moment the two spacecraft rose from their launch pads to begin the grand tour, the story opened like a doorway into realms that had existed only in imagination. And from that very point of departure, Voyager's farewell to its homeworld became the next quiet, resonant chapter in humanity's cosmic symphony. After separating from the final stage of the Titan rocket, Voyager began its true flight, a flight no longer bound by Earth's gravity. Earth now lay behind, round and blue, like a glowing gem suspended in infinite darkness. If one could look through an imaginary window on the side of the spacecraft, the scene would unfold slowly. The blue of the oceans softening shade by shade, the bright white clouds thinning out, the continents fading into pale shapes. And then, in time, the entire planet would shrink into a small, pale blue dot. So tiny it could be covered by the tip of a pencil if someone were standing next to Voyager. That moment felt like a gentle goodbye, as if the spacecraft were slipping out of Mother Earth's embrace, carrying with it the last memories of the home that gave it life. Soon after leaving Earth behind, Voyager entered interplanetary space, a realm without atmosphere, without sound, without any familiar color. Only an almost perfect emptiness remained, where particles were so sparse they could be counted by the handful in each cubic meter. Sunlight here was still bright enough to illuminate the spacecraft's details, but its intensity faded swiftly with every million kilometers of distance. The surrounding stars grew sharper without Earth's air to blur them. They hung motionless against the deep black, like grains of glitter scattered across a vast velvet cloth. Along the way, a stray mote of dust might drift by, or a high-energy cosmic ray might flicker through the sensors, leaving the faintest trace. A reminder that space, for all its emptiness, was not completely void. Before reaching Jupiter, Voyager had to cross the asteroid belt, a vast region between the orbits of Mars and Jupiter, where millions of fragments of rock and ice circle the Sun. In the popular imagination at the time, this region was thought to be dense and dangerous, like a wall of stone. But when Voyager passed through it, the reality proved entirely different. Although countless asteroids existed, the distances between them stretched hundreds of thousands of kilometers. Voyager encountered no obstacles at all. Its instruments detected very few large dust particles, only an occasional blip, like a quiet reminder that the spacecraft was passing through an ancient realm where leftovers from the solar system's birth still drifted silently. The crossing was so peaceful, it could be compared to gliding through a sparse stone forest without brushing against a single pebble. The journey from Earth to Jupiter took nearly 2 years, most of which Voyager spent drifting in silence, steady, stable, and unhurried. Its systems ran in a minimal configuration to conserve power. Only the instruments needed to measure solar wind, radiation, and plasma remained active. Each day, Voyager sent back a small stream of radio signals, so faint that by the time they reached Earth, their strength had diminished by a factor of 1 trillion, no brighter than the glow of a refrigerator light. Yet the enormous antennas of the deep space network listened patiently, decoding every bit. Like steady heartbeats, Voyager's signals reassured mission controllers that the spacecraft was healthy, precisely on course, and drawing closer to the first destination of the Grand Tour. On Earth, in the control rooms of the Jet Propulsion Laboratory in California, scientists and engineers followed Voyager with a mix of patience and anticipation. They knew the moment Voyager approached Jupiter would become historic, the first time humanity would see the giant planet from such a close range. Each day they reviewed data, calculated trajectories, checked the spacecraft's status, and prepared fine-tuned commands. None of them were physically near Voyager, yet those distant radio whispers, traveling for hours across space, made the spacecraft feel like a child far from home, taking steady steps through the vast darkness. Every update was awaited eagerly. Every delay of even a few minutes tightened the room with worry, only for relief to wash over them when familiar numbers finally appeared. Hope, tension, pride. All these emotions blended together, adding a special warmth to a story unfolding in a place just a few degrees above absolute zero. The farther Voyager traveled, the more it left behind the final traces of familiarity. The solar system simplified into a few orbits of faint dots, each dot a planet quietly circling the Sun as it had for billions of years. Voyager, tiny compared to any celestial body, was merely a speck of metal drifting alone in the night. Yet that very solitude revealed the meaning of the mission. A human-made object had dared to leave the place that created it, venturing into a boundless region with no path back home. And from the moment Earth faded behind it, to the moment it entered deeper interplanetary darkness, every step became a new sentence in the story humanity was writing with the universe. That stretch of hundreds of millions of kilometers was only the beginning, the prelude to Voyager's first encounter with Jupiter, a destination generations of scientists had dreamed of. But before the story turns toward that giant world, the moment of leaving Earth remains one of the most beautiful chapters, for it is the instant Voyager became a true emissary of humankind, setting out to write a grand travelogue among the stars. From the moment Voyager drifted away from Earth and into interplanetary darkness, its journey became a slow current flowing toward worlds humanity had only glimpsed through telescopes. And from within that long stretch of silence, the next milestone began to emerge, like a gigantic painting gradually brightening in the cosmic night. The largest gas planet in the solar system. More than 2 years after waving goodbye to its blue home, Voyager began to sense the first shift in the sky ahead. In the earliest days, Jupiter was nothing more than a dot slightly larger than the nearby stars, hardly different to the naked eye. But week by week, month by month, that dot swelled, brighter, fuller, clearer. From afar, the giant planet first appeared as a faint smudge, then a pale disk, and eventually a circle touched with traces of color, hinted at only briefly in the early data sent home. By 1979, Voyager had come close enough to realize that the planet before it was not only enormous, but oddly radiant. The spacecraft's cameras began to capture cloud bands stretched out like brushstrokes painted with the softest hand. Ivory white streaks intertwined with warm oranges and deep reds, swirling together in winds far stronger than anything that exists on Earth. From a distance, Jupiter looked like a vast sphere without a solid surface. Everything was gas, wind, and colossal spirals churning within its endless atmosphere. As Voyager drew nearer, it felt almost like the spacecraft was entering that cosmic painting, slowly, completely. From millions of kilometers away, its cameras could now resolve the crisp edges of cloud belts, revealing patterns of light and shadow that were orderly yet mysterious. Inside its guidance system, everything remained steady. The sensors continued to measure radiation and the solar wind. But the images sent home each day became a source of wonder for those watching from hundreds of millions of kilometers away in JPL's control rooms. The closer Voyager moved into Jupiter's gravitational system, the more powerfully it felt the planet's pull. Space remained silent, yet the spacecraft's telemetry showed its speed rising as Jupiter's mass drew it inward. Voyager's path began to curve, not because it steered, but because Jupiter's gravity reached out like an invisible hand, reshaping its trajectory. All of this unfolded exactly as planned. Voyager was designed to use that gravity as a lever to slingshot past Jupiter and accelerate toward its next grand tour destination. This technique is called a gravitational assist, but in simpler terms, one could imagine Jupiter as a giant rubber post. A small marble passing nearby is tugged toward it briefly, then flung forward with greater speed. That is precisely what Voyager was experiencing. It was about to glide close to the gas giant, receive a carefully calculated push, and head toward Saturn and beyond. Thanks to this technique, Voyager 2 would eventually reach Uranus and Neptune as well, worlds no other spacecraft had visited. While Voyager entered Jupiter's gravitational domain, Scientists on Earth felt as if they were living each moment with the spacecraft. Data and images added to humanity's growing portrait of the gas giant, and every confirmed measurement sent waves of excitement across the team. One scientist recalled that each day approaching Jupiter felt like opening a new page of a book no one had ever read. He said he had never before seen humanity learn so many new things in such a short span as during the Voyager's encounters with the giant planets. His words were repeated for decades because they captured exactly what the entire team felt. Astonishment at a place both beautiful and immense, filled with mysteries larger than imagination. From afar, Jupiter resembled a cosmic treasure chest that Voyager was slowly unlocking. Its atmosphere was anything but calm. Beneath the cloud layers were winds reaching hundreds of meters per second, forming vortices so enormous they could swallow Earth whole. Among them was the Great Red Spot, a storm that had raged for centuries, one of the most extraordinary weather phenomena in the solar system. Voyager had not yet passed close enough to see it clearly, but hints of its swirling form already appeared as a darkened spiral beneath the clouds. Jupiter was also surrounded by a diverse family of moons, each a world with its own distinctive character. From this distance, Voyager could not yet see their surfaces, but their orbits appeared as tiny points of light circling the giant planet. The scientists knew that as Voyager approached, the secrets of those moons would begin to unfold. Io, Europa, Ganymede, Callisto, the four great moons, carried stories Voyager would soon reveal. Voyager's approach to Jupiter was more than just a phase of the mission. It was a moment when humanity came closer than ever to a planet we had only viewed through the lens of a telescope. Jupiter's splendor did not lie only in its sheer size, but in the colors, the spirals, the fathomless layers of gas, a living artwork shaped by nature itself. As Voyager continued toward its closest approach, as the images sharpened day by day, as details grew clearer than anything humans had ever seen, the path ahead felt like a symphony rising in volume. And within that gentle crescendo, Voyager's story at Jupiter was preparing to turn the page, toward a new chapter where extraordinary discoveries would begin to appear, one by one, like gifts the universe offers to those bold enough to journey far beyond home. From the moment Voyager drew near to Jupiter and watched the giant planet rise like a living painting, its journey entered a new, vividly colored chapter. And in that very moment of approach, a doorway into Jupiter's majestic, storm-filled world slowly opened, revealing scenes humanity had only dreamed of through the faint, distant images gathered by telescopes. As Voyager reached the closest region of space around Jupiter, its cameras began sending back images the world had never seen before. The entire planet appeared like a colossal work of art, painted with nothing but gas and wind. Bands of cloud curled into massive layers wrapping around the planet's surface, forming broad stripes of pale orange, reddish-brown, creamy white, and at times a soft amber glow. Each cloud band stretched tens of thousands of kilometers, twisting into one another under the pull of supersonic winds. Looking into these layers felt like watching an endless dance, where every color blended effortlessly, naturally, and with a quiet grace. Immense swirling clouds stood out like gentle brushstrokes on a vast canvas that was slowly in motion, and Voyager was fortunate enough to witness all that softness, all that fluid beauty. Among all the cloud formations Voyager recorded, the Great Red Spot captured attention more strongly than anything else. It was a massive swirling storm, so large it could hold 2 or even 3 Earths within its bounds. Having persisted for centuries without fading, the Great Red Spot appeared as a deep, brick-colored vortex, like an eternal tropical cyclone. In the images sent home, the churning oval looked like a gigantic eye, endlessly rotating, pulling the surrounding clouds into its rhythm. The vision was both dreamlike and haunting, as though one were staring into an ancient mystery nature had guarded for hundreds of years. And somehow, in all its enormity, the storm carried a quiet beauty, like a deep corner of the atmosphere softly whispering its own private story through the steady, rhythmic spin of its winds. Though Jupiter's atmosphere is a realm of chaos with furious storms and sweeping vortices, Voyager observed everything from afar with the calm of a wanderer untouched by wind or sound. Measurements revealed that Jupiter's winds could reach hundreds of meters per second, stronger than any hurricane ever recorded on Earth. Clouds moved across multiple layers, swirling one way here, curling another way there, forming flows of mesmerizing complexity. And yet, when folded gently into the narrative, all that turbulence transformed into something serene, like a slow-motion dance of nature. As if even storms possessed their own quiet melody, and Voyager stood silently at the edge of the cosmic stage, watching the choreography unfold. One of the discoveries that most surprised scientists was the existence of Jupiter's ring system. Before Voyager, almost no one believed the planet had rings at all, as they were far too faint to observe from Earth. But as the spacecraft passed by, its cameras revealed delicate bands of dust encircling the planet. At first glance, they resembled a barely there halo, made of countless tiny particles of rock and ice that reflected sunlight only as a thin, silver shimmer. This discovery suggested that Jupiter wore a sort of gentle scarf, shining faintly in the darkness, barely noticeable yet undeniably present. Subtle, unexpected, and quietly beautiful, the rings revealed that even a gas giant of overwhelming scale held its own delicate grace. Beyond the cloud bands and the faint ring, Jupiter's magnetic field was something Voyager had to take special note of. Its magnetosphere was colossal, stretching across a region of space millions of times larger than Earth. As Voyager entered this zone, its radio wave detectors began sensing powerful changes. The solar wind bent and rippled as it met Jupiter's magnetic field, creating oscillations captured as signals by the spacecraft. These signals sounded like gentle, rhythmic humming, waves of electromagnetic energy passing softly over its frame. Through them, Voyager understood that it was entering one of the strongest magnetic structures in the entire solar system. While scanning Jupiter's north and south poles, Voyager also captured images of auroras, ribbons of blue and violet light dancing in the dark. They resembled the auroras on Earth, but infinitely larger and far more radiant when viewed from space. These luminous arcs were created as charged particles from the solar wind interacted with Jupiter's magnetic field, painting shimmering trails that looked like glowing silk floating across the upper atmosphere. Many scientists were moved by these images, sensing that even in the most violent environments, the universe still found ways to create moments of breathtaking beauty. When the first images and data from Jupiter reached Earth, the reaction among scientists was a mix of astonishment and joy. The sharp details, the richly colored cloud patterns, and the long-hidden mysteries finally revealed made them realize Voyager had achieved more than anyone imagined. Some said humanity had never seen Jupiter this close, never truly felt the planet's real beauty. They described the experience like recalling a cherished memory. Hundreds of people gathered around displays, waiting for each line of data, each bright pixel to appear. And when the full picture finally emerged, a warm wave of emotion swept through the room. The images Voyager brought home did more than expand human knowledge of Jupiter. They touched something deeper in those who had been following the journey from Earth. It was a moment when science became more than numbers or equations. It became art. The art of discovery, the art of witnessing, and the art of honoring the universe's quiet wonders. And as Voyager drifted away from Jupiter's colorful atmosphere toward its next encounter, a new doorway opened, leading to the fascinating moons orbiting the giant planet. From here, the story would travel even deeper into those small yet mysterious worlds that Voyager was about to explore. From the moment the first images of Jupiter's colorful atmosphere arrived back on Earth, the story of the giant planet opened before humanity like a vast doorway. And as that magnificent atmosphere came into view, the path leading Voyager toward the tiny worlds orbiting Jupiter also began to unfold, revealing secrets even more wondrous than the planet's eternal storms. Jupiter is not merely a gas giant. Around it drifts an entire miniature solar system. Dozens of moons circle the planet, each with its own shape, its own history, and its own quiet beauty. Among them, the four largest, Io, Europa, Ganymede, and Callisto, are known as the Galilean moons, named for Galileo, who discovered them in the 17th century. When Voyager approached, these four worlds felt like four chapters waiting to be opened, and each chapter held a surprise no one had imagined. Among these moons, Io delivered the greatest shock. Before Voyager, scientists believed Io was an icy, barren moon, no different from the many small, quiet bodies scattered throughout the solar system. But when Io's image appeared on the screen, all earlier assumptions collapsed at once. Io was anything but still. On its surface, Voyager saw strange glimmers rising from the horizon, shapes that looked like enormous plumes, spreading outward like colossal feathers reaching into the sky. These were volcanic eruptions, fountains of dust and gas shooting hundreds of kilometers high, something almost impossible to picture without seeing it firsthand. The photographs Voyager sent revealed Io as a world in constant motion. Its surface was coated in sulfur, glowing in shades of yellow, orange, and red, cut through by wide volcanic depressions. Some regions even changed color within months, a sign that geological activity never rested. When scientists studied the first images, Ed Stone, Voyager's project scientist, remarked, "The eruptions on Io are the first direct evidence of active volcanism anywhere beyond Earth. This astonishing discovery signals that many more surprises are waiting for us." In that moment, Io transformed humanity's old notions about frozen moons into an entirely new horizon, one where energy and upheaval could thrive even in distant alien worlds. After Io, Voyager turned its attention to Europa, a moon entirely different in character. If Io burned bright and fierce, Europa felt quiet, cold, and profoundly mysterious. In Voyager's images, Europa appeared like a smooth marble sphere, its surface made mostly of bright, unbroken ice. But what made Europa truly captivating were the thin, winding lines, brownish, reddish streaks, etched across its surface like ink bleeding through white parchment. These lines were not the result of asteroid impacts. They were signs of movement beneath the ice, as though the surface had stretched, cracked, and drifted gently over a liquid layer below. That idea stunned scientists. If a layer of water truly lay beneath Europa's icy shell, then the moon might hold a vast global ocean, one that could be deeper than all the oceans on Earth combined. And in a place that seemed freezing, dark, and lifeless, the presence of liquid water opened a possibility both fragile and electrifying: life. Voyager had no tools to pierce the ice, Yet the images it captured were enough to plant a question in humanity's imagination, one that would echo for decades. Could anything be living beneath that frozen sea? From that moment on, Europa became one of the most promising places for life beyond Earth in the entire solar system. While Io and Europa delivered dramatic revelations, Voyager also turned briefly toward the remaining Galilean moons, Ganymede and Callisto. Ganymede is the largest moon in the entire solar system, even bigger than Mercury. As Voyager passed by, its photos showed a surface divided between dark and light regions, forming a complex geological mosaic. Long grooves, almost like deep scars, hinted that forces inside the moon had once reshaped the terrain. Ganymede was not a silent, lifeless world, as many had assumed. It carried the marks of a rich geological history, heating, shifting, cooling, playing out over immense spans of time. Callisto, by contrast, told a gentler story. This older, calmer moon was covered with overlapping craters, like layers of slow-moving time pressed into its surface. Through Voyager's lens, Callisto resembled an ancient letter written by the universe itself, each crater an echo of collisions billions of years old. Callisto was not fierce like Io, nor mysterious like Europa, nor complex like Ganymede. Yet its stillness held a beauty of its own, like two gray jewels circling Jupiter in perfect silence. As Voyager left Jupiter and continued outward toward more distant rendezvous in the solar system, scientists reviewed the images of Io, Europa, Ganymede, and Callisto with a kind of quiet wonder. They were not simply looking at 4 moons. They were looking at 4 worlds, each with its own personality, its own story, its own history. And all of it existed right beside the giant planet humanity had long thought of as nothing more than a swirling mass of stormy clouds. Thanks to Voyager, humanity realized that the universe's wonders are not found only in the great planets, but often in the small moons that circle them. And from that sense of awe, a new understanding began to form, that a single planet could hold an entire hidden kingdom, waiting only for a small traveler to pass by and give it a voice. And as the journey moved forward, Voyager turned its gaze toward the second giant planet, where new secrets waited quietly to be discovered. Just as the final wonders of Jupiter's moons were still lingering like the fading notes of a gentle melody, Voyager's journey continued to unfold along a new curve in its trajectory. And from the moment those mysteries were fully recorded, the doorway to its next destination in space began to open, guiding the 2 small spacecraft toward a world often compared to a golden jewel of the solar system. Jupiter slowly drifted behind, like a colossal god of gas offering a quiet farewell to the traveler. Voyager received a powerful gravitational boost from the planet, turning its pull into new momentum that carried the spacecraft farther, toward a fragile ring of light waiting ahead. In the deep darkness, Jupiter shrank to a large, hazy glow, like the silhouette of a giant dissolving into the night. The moment carried a tender sense of longing, for the realm it had just left was filled with tiny, mysterious worlds. Yet alongside that softness was an undercurrent of anticipation, because ahead lay a planet whose beauty generations of people had admired through telescopes. The space between the 2 planets stretched into a vast emptiness. Voyager entered that cold, shadowed region where sunlight was already much weaker than it had been near Earth. From this distance, the sun was simply a bright but tiny star, floating among countless others. The spacecraft's nuclear power source still supplied steady electricity, but the surroundings resembled an endless night. No sound, no wind, only the absolute stillness of interplanetary space. The journey spanned hundreds of millions of kilometers, and it felt as though Voyager was drifting across a dark, tranquil ocean, quiet and at peace. In that immense darkness, the two Voyager siblings still traveled side by side, though each carried a different destiny. Both Voyager 1 and Voyager 2 were headed towards Saturn, but calculations from Earth had set them on separate paths. Voyager 1 was planned to fly close to Titan, Saturn's largest moon, a world wrapped in thick orange haze and long shrouded in scientific curiosity, its surface hidden from nearly all light. Meanwhile, Voyager 2 was set on a different trajectory, one that would allow it to continue much farther, beyond Saturn, toward the distant ice giants. The two siblings had left Jupiter together, but like a river branching into two streams, each began flowing toward a different land. Time drifted quietly by. Nearly a year after leaving Jupiter, Voyager 1 spotted a tiny pale yellow dot ahead. At the same time, Voyager 2, slower but steady, was approaching the same destination. From tens of millions of kilometers away, the planet appeared as nothing more than a soft, glowing speck. But as the spacecraft drew nearer, that golden star transformed into a stunning sphere. A thin line of light encircled it, delicate as a strand of hair, yet clear and unmistakable. It was Saturn's famous ring system, long shown in books and artwork, but never seen by human eyes in its full, authentic splendor. Voyager moved closer. The thin line began to divide into many separate rings, not a single band, but thousands of shimmering loops woven together like silver threads glistening in the dark. These rings made the planet appear as though it were draped in a delicate scarf made of ice and stone. With every kilometer Voyager advanced, the complexity of the rings sharpened, like a work of art carved directly by the universe. This was not imagination, not an illustration from a textbook, but reality. Seen through the camera of a small spacecraft that had traveled billions of kilometers to reach this place. As Voyager approached, scientists on Earth felt their excitement growing. They all understood that, despite knowing of Saturn's rings for centuries, Voyager would be the first to reveal their true nature. People had long wondered, what exactly were these rings made of? Rock? Ice? Something else entirely? Were they continuous or broken into countless pieces? And within the space surrounding Saturn, beyond those exquisite rings, what other mysteries might be hiding? These questions quietly pulled Voyager closer, like a soft current drawing it into the heart of a long-awaited scene. The sight of the golden planet swelling in the spacecraft's field of view felt like a slow, cosmic sunrise. No rush, no noise, only the gentle unveiling of a landscape humanity had dreamed of seeing up close for centuries. As Voyager reached a distance close enough to resolve the outer edge of the rings, a natural question arose. Up close, what will those shining loops truly look like? Are they really made of tiny crystals of ice? Or do they hold structures no one has ever imagined? These questions weren't meant to create suspense, but more like a soft whisper, a tender curiosity inviting the listener to drift deeper into the flow of the story. Voyager continued forward, cutting through darkness, gliding past endless silence. And there ahead, the ringed planet awaited with a beauty even human imagination had struggled to capture. The journey from Jupiter to Saturn was not just a long flight. It was a gentle transition from one set of wonders to new, untouched mysteries, from turbulent moons to a world wrapped in luminous circles as fragile as moonlight on a lake. And now, the story was preparing to turn a new page, one where Voyager would begin exploring one of the most iconic sights in the entire solar system, Saturn's rings, a masterpiece woven from glittering ice and ancient stone. All of it waited in the next chapter of the journey. As the golden planet began to grow within Voyager's view, space itself seemed to shift in tone. Like a gentle transition between chapters, from the wonders just explored to a new, more radiant one waiting ahead. And from the first moment Saturn's delicate rings appeared in the distance, the story opened once more, revealing another softness the universe had quietly tucked away. Saturn emerged before Voyager like a painting no artist had crafted, yet somehow flawless. Against the deep black of space, the pale golden sphere glowed with a tender light, not dazzling, but graceful enough for one to feel the elegance in every curve of the planet. Wrapped around that sphere was its famous ring system, soft, luminous bands like the breath of an invisible artist. From afar, they appeared as thin circles, no more than faint strokes of light. But as Voyager moved closer, the rings separated into distinct layers, like sheets of delicate silk, stacked one atop another around the planet. Someone once said that if the solar system were an art gallery, Saturn would surely be its centerpiece. For when Voyager reached a distance close enough to send back its first images, the planet appeared in a brilliance no textbook illustration could ever capture. Saturn floats like a golden disk surrounded by fragile, glimmering rings, enough to move even the driest of hearts. It was not only a description, it was the true feeling of those who had waited years for this moment. As Voyager entered the region of the rings, it began transmitting images that astonished the world. What had once looked like solid bands were, in truth, woven from countless pieces of ice and rock, each no larger than a grain of sand, yet together forming endless arcs of shimmering light. Sunlight reflected off them, making the rings appear to glow from within. Voyager revealed that this system consisted not of a few broad rings, but of thousands of narrow ones layered together, separated by dark gaps like massive grooves on a cosmic record. In several images, Voyager even captured faint shadows sweeping softly across the rings, mysterious spokes. They looked like stretched shadows drifting across the icy bands, appearing and disappearing with no clear pattern. Only years later would scientists understand that these spokes were caused by electrically charged dust interacting with Saturn's magnetic field. But at the time Voyager observed them, they felt like tiny secrets the universe had chosen to hide just a little longer. Up close, what looked like smooth rings turned out to be woven from countless icy grains. And in some regions, Voyager glimpsed fleeting shadows, spokes, sliding across the bands, mysteries we would not understand until much later. The universe always knows how to surprise us. Among the rings, the F ring was one of the most enchanting. It was so thin it looked like a single narrow glimmer of light. Yet as Voyager approached, the F ring revealed gentle twists, like a ribbon caught in an invisible breeze. Its shape shifted over time under the influence of small companion moons, creating a beauty both fragile and deeply mysterious. Beyond the rings, Saturn's atmosphere came into clearer view. Unlike Jupiter's bold orange hues, Saturn's clouds were softer, dressed in shades of creamy gold and pale streaks. The winds there still roared at tremendous speeds, yet through Voyager's camera, they appeared oddly peaceful, like a rolling ocean of clouds without a hint of violence. And yet within that seemingly calm world lay a remarkable feature: the famous hexagonal storm at the North Pole. At the pole, clouds and winds form a perfect hexagon, a natural structure so improbable it feels as though Saturn carries a six-sided emblem at its crown. The hexagon looked like the universe signing its name, an impossible shape made real. Within Saturn's magnetosphere, Voyager continued gathering data. The planet's magnetic field was not as strong as Jupiter's, yet powerful enough to produce radio waves, radiation zones, and auroras. The radio sounds Voyager recorded there resembled soft buzzing mixed with faint crackles, like the deep, rhythmic pulse of an unseen orchestra. Drifting through Saturn's magnetic realm, Voyager listened to the whisper of the field, strange humming tones, like the instruments of the cosmos lulling themselves to sleep. For scientists, these were precious measurements, but for those listening with their hearts, it sounded like the universe humming a lullaby. When the first images of Saturn returned to Earth, the emotions within mission control seemed to merge into one. Not loud, not explosive, quiet, profound. Many recalled sitting silently before the screens, unable to speak as the beauty unfolded. They described Saturn as a delicate treasure suspended in the void. Not a showy beauty, but one so refined it made people feel small, humbled, and grateful just to witness it. Every ring, every cloud band, every tiny detail deepened the sense that the universe held far more gentle wonders than humanity had ever imagined. What Voyager saw at Saturn was not just scientific data. It was beauty, sheer, serene beauty, a gift the universe had entrusted to a small spacecraft, carrying humanity's curiosity. And within that beauty, the chapter around the golden planet gently drew to a close, preparing to open another, where Saturn's moons awaited with quiet secrets of their own, ready to be revealed. After Voyager had taken in the full beauty of Saturn's shining rings, the story of the golden planet felt like a chapter closing softly, with a gentle sense of fulfillment. And from the moment those luminous bands slipped behind the spacecraft, Voyager's gaze began drifting towards Saturn's small companions, quiet little worlds that seemed unassuming, yet held entire vaults of secrets waiting to be told. Orbiting Saturn was a grand entourage of more than 80 moons, though Voyager could visit only a handful along its path. Even so, those few were enough to reveal a world far richer than anyone expected. Around Saturn, Voyager visited a procession of moons, each with its own story. Like walking down a long hallway lined with doors to tiny universes, Voyager tapped lightly on each one, and behind every door lay something no one could have imagined. Among these moons, Titan soon became the central figure of the encounter. Titan is the second largest moon in the entire solar system, just slightly smaller than Ganymede, but its uniqueness set it apart completely. As Voyager 1 approached Titan, the spacecraft immediately sensed this was no ordinary world. Titan was wrapped in a dense orange haze, like a veil of secrecy draped over its entire surface. Not a single ray of reflected light escaped to reveal what lay beneath. Voyager's cameras recorded only a muted amber sphere, still mysterious and completely hidden behind clouds. That haze was like a locked door, leaving Voyager only to imagine what waited below. Titan greeted Voyager with a deep orange fog, hiding every secret beneath it. All the spacecraft could know was that under those clouds lay a frozen world, at 170 with a nitrogen-rich atmosphere even thicker than Earth's. Titan is one of the very few moons in the solar system with such a dense atmosphere. When Voyager analyzed the sunlight filtering through the haze, it found that nitrogen made up nearly the entire atmosphere, something only Earth had known until then. Alongside it was methane, a volatile compound that behaved on Titan the way water behaves on Earth. It could condense, evaporate, form clouds, and even fall as rain. The The methane on Titan suggested the possibility of methane rain and hydrocarbon seas on the surface. A strange world where the rain might not be water, but liquid gas. Imagining such a place made Titan feel distant, yet eerily familiar. A reversed version of Earth. Thick atmosphere, clouds, rainfall, winds blowing across icy hills. But the materials were different. Water was rock-hard ice. Methane was liquid. That inversion made Titan one of the most intriguing worlds Voyager would ever encounter. While Titan stole the spotlight, Voyager also drifted past Saturn's icy moons, each leaving its own impression, like dim gemstones shining gently in Saturn's glow. Enceladus, small but striking, stood out with its mirror-like surface nearly untouched by impact craters. This surprised Voyager, a moon so bright, so youthful, its surface unmarked by the scars of time. Although Voyager never witnessed the dramatic water plumes later captured by Cassini, it still sensed that Enceladus carried signs of quiet geological activity. Then came Mimas, a small moon with a colossal impact crater that made it resemble the famous Death Star. One hemisphere appeared almost caved in, while the rest was pitted with smaller craters, as though Mimas had endured a violent past before settling into silence. Voyager saw it only briefly, but that was enough to carve its strange image into human memory. Iapetus told yet another story. This moon had two starkly different halves, one dark as charcoal, the other bright as snow. The dramatic contrast made it one of Saturn's strangest moons. Voyager passed Enceladus, bright as polished ice, then Mimas with its massive scar, then Iapetus with its half-black, half-white face, each moon a tiny gemstone orbiting its parent planet. And beyond these well-known names were Rhea, Dione, and Tethys, quieter moons, yet each holding the serene beauty of ancient ice. While Voyager was busy collecting clues from Titan, scientists on Earth followed every moment as if holding their breath. Titan intrigued them so deeply that decades later, humanity chose to return, sending the Huygens probe to land on Titan's surface. That event would come long after, but even in Voyager's early glimpses of Titan's orange shroud, people already knew they would be back. Titan hid its secrets from Voyager, but its mystery only pulled us closer. Such is the beauty of science. There is always something new to discover. Titan became an invitation to the future, a reminder that the journey of exploration never truly ends. For Voyager 1, the visit to Titan was not only the pinnacle of its time around Saturn, it was also its farewell to the inner solar system. Because it flew so close to Titan to study its atmosphere, the spacecraft was forced onto a trajectory that carried it out of the ecliptic plane, meaning it could no longer continue toward planets like Uranus or Neptune. Voyager 1 seemed to accept this destiny like a traveler who had completed a grand tour of the major cities, now choosing a distant road leading toward places no one had ever seen. After its meeting with Titan, Voyager 1, like a traveler finishing a tour of remarkable worlds, slowly left the main stage. Behind it, Saturn with its rings and moons gently slipped away. And from that moment, Voyager 1 entered the longest chapter of its life, the journey toward the edge of the sun's influence, where the solar system ends and interstellar space begins. But that is the story of the next part. When Voyager leaves the familiar planets behind and heads for the infinite frontier of the cosmos. As Titan slowly slipped back into its signature orange haze and Voyager 1 drifted away from Saturn's icy retinue of moons, the scene behind it felt like the closing of a chapter, one both mysterious and tender. And in that very moment, the journeys of the two robotic travelers began to diverge, like two rivers born from the same spring but flowing toward far-flung corners of the galaxy. Voyager 1, after its crucial encounter with Titan in late 1980, entered the decisive turning point of its mission. Flying so close to Titan forced the spacecraft to veer upward, away from the flat plane where the planets lie. From that moment on, Voyager 1 would never meet another planet again. Ahead of it stretched the vast realm of interplanetary space, where the final boundaries of the Sun's influence were slowly revealing themselves. Voyager 1 left the procession of planets, heading upward like a traveler stepping away from the group, carrying with it the dream of reaching the edge of the space between the stars. Below it, the planetary orbits shrank into a thin, glowing disk, like a stage it had stepped away from to enter the quiet backstage of the universe. While Voyager 1 exited the planetary theater, Voyager 2 still had a long journey ahead. Because it did not need to detour toward Titan, Voyager 2 caught Saturn's gravitational slingshot, bending its trajectory toward the seventh planet of the solar system. Voyager 2 took Saturn's push and turned toward Uranus. It became the first, and still the only, spacecraft ever to visit Uranus, and later Neptune. A rare path, a complete grand tour, one unlikely to be repeated for centuries. Comparing the two journeys, people often imagine them as siblings standing at a fork in the road. Like two brothers at a crossroads, Voyager 1 turned aside to chase the dream of starbound space, while Voyager 2 followed the established road of the planetary system. The two had once traveled side by side, crossing the expanses between planets, witnessing the mighty storms of Jupiter and the enchanted rings of Saturn. But now, each carried its own mission, like characters in a cosmic epic stepping into two different chapters of the same story. For Voyager 2, the path from Saturn to Uranus would take nearly 7 years, a stretch so long that numbers alone can hardly convey the stillness of that journey. No major planets appeared along the way, only the cold emptiness stretching out endlessly ahead. Year after year, Voyager 2 pressed forward through the frigid void. Occasionally, radio signals from Earth reached it, checking the spacecraft's health. Sometimes, Voyager 2 entered an electronic sleep, systems going quiet to save power, waiting to awaken as it drew closer to its target. The image of a robotic spacecraft hibernating in space carried a lullaby-like stillness, perfectly matching the slow drift through the quietest realm of the solar system. During those 7 years, Voyager 2 was never truly alone. From Earth, faint but persistent signals kept coming, traveling billions of kilometers to reach it, and Voyager 2, like a steadfast traveler, replied with its steady beep, the only echo in the deep silence of space. Both spacecraft, on their separate paths, displayed a resilience far beyond anything their creators had expected. Indeed, by the early 1980s, both Voyager 1 and Voyager 2 had already lived far longer than planned. The original mission had been expected to last about 5 years, just long enough to reach Jupiter and Saturn. Yet the spacecraft continued running reliably, despite radiation, freezing temperatures, and the aging of their electronic systems. No one imagined the two little spacecraft could endure this long, one scientist recalled. Ed Stone, the face of the Voyager mission, once said, "We don't know how big the heliosphere is, nor whether the spacecraft can survive long enough to reach its edge." His words carried both worry and awe, a candid admission that Voyager had exceeded even the hopes of those who built it. While Voyager 1 climbed steadily above the ecliptic plane toward the edge of the heliosphere, Voyager 2 pressed forward on its long path, waiting for the day it would meet the first ice giant. The two spacecraft flew off in directions increasingly far from each other, yet remained bound by the same purpose: to tell the story of places no one had ever seen. For Voyager 1, the sky ahead was the darkness of an undefined frontier, where it would soon confront the final boundary of the solar system. For Voyager 2, the next destination was Uranus, a pale blue-green world awaiting the first human visit in history. This moment of divergence didn't just mark the technical split in their paths. It became one of the most beautiful images in the entire Voyager story. One spacecraft leaving the main stage for the road to interstellar space, the other diving deeper into the planetary realm. Two directions, yet both opening new chapters of humanity's knowledge. And so, as each spacecraft's path grew clearer, the story gently invited listeners to continue onward. Voyager 1 slipped quietly toward the border of the solar system, while Voyager 2 pressed on toward worlds no human had ever seen. The adventure was far from over. New chapters waited ahead, in the deep and quiet dark. It was a reminder that the wonder of astronomy never lies in finishing the journey, but in knowing that there are always more secrets waiting somewhere beyond, where sunlight fades and new stories begin. As Voyager 2 left Saturn behind and began its 7-year glide through darkness, the space ahead of it felt like a still, unbroken lake. And from that very stillness, a faint blue world slowly emerged in the distance, like a long-forgotten secret from the earliest days of the solar system. It was the next rendezvous Voyager 2 had been patiently traveling toward for nearly a decade. Uranus, the 7th planet, a world once seen only as a blurry smudge in old telescopes. For centuries, humanity had known it only through equations and limited observations, yet no one had ever seen its true face. Before Voyager 2, Uranus was simply a name floating in the great empty span between Saturn and Neptune. And so, as the spacecraft drew near in January of 1986, the anticipation felt hushed, gentle, like a held breath drifting through space. After a long and quiet journey, Voyager 2 finally arrived at the icy kingdom of Uranus, a place no spacecraft had ever visited. The first images brought both surprise and silence. Through Voyager 2's camera, Uranus revealed no colorful bands like Jupiter, no brilliant rings like Saturn. Instead, the planet appeared as a pale blue sphere, smooth, muted, almost motionless. That blue hue came from methane-absorbing red light, leaving behind a soft, cold tint. But the most striking feature was its bizarre axial tilt. Uranus is like a giant lying on its side, asleep, its pole nearly pointing toward the sun. Seasons last for decades, and day and night behave in strange, uneven cycles at the poles. The planet didn't spin like a top. It rolled around the sun like a tilted barrel. The strangeness of Uranus did not end there. Although its cloud tops looked still, Voyager 2 revealed unexpected discoveries. One of them was the planet's dark, faint ring system, first hinted at years earlier when astronomers noticed starlight dimming as something passed in front of it. Voyager 2 captured those slender, shadowy rings, nothing like Saturn's bright, icy loops. Not dazzling like Saturn's rings, Uranus's rings were thin and dark, like black ink strokes drawn across a pale blue canvas. They circled quietly, as though they were fragile remnants of a cosmic history blurred by time. Voyager 2 also expanded the moon family of Uranus. Before the flyby, humanity knew only 5 major moons: Titania, Oberon, Ariel, Umbriel, and Miranda. But the spacecraft discovered 10 additional small moons, bringing the total to 15 at the time. Many of their names came from Shakespeare, as if the universe had borrowed literature to christen these tiny worlds. Names once found only in stories became real worlds Voyager had the privilege to pass. Among the moons, Miranda was the most striking. Despite its small size, Miranda's surface was astonishingly complex. Voyager 2 captured towering cliffs and bizarre patchwork terrain, as though the moon had shattered and reassembled itself in some forgotten era. Miranda looked like a mismatched mosaic, smooth plains in one place, deep chasms up to 20 kilometers in another, like an unfinished sculpture. Perhaps Miranda once broke apart and fused again. That mystery was Voyager's gift to the generations that followed. The grooves, the fractured landscapes, the cliff walls rising like frozen waves. Miranda became one of the strangest moons in the solar system. And yet the feature that gave Voyager 2 the deepest sense of calm was Uranus's extraordinary stillness. No raging storms like Jupiter, no glowing auroras like Saturn. Uranus felt like a world asleep. Voyager 2 skimmed past Uranus's quiet cloud tops at over 60,000 kilometers per hour, yet nothing seemed to stir beneath it. Everything was hushed, as if the icy planet were resting. In that silence was a soothing quality, a distant, frozen world serene as a deep, unmoving lake. Though Voyager 2's visit to Uranus lasted only a few hours, it sent back thousands of images and invaluable data. Those images became the first pages in the story of a planet that had once been only a pale, anonymous dot. Before leaving, Voyager 2 sent back thousands of photos and measurements, opening the first chapter on Uranus, a world that until then had no face, no story. And then, when every observation was complete, Voyager 2 continued its voyage, departing Uranus and heading toward the final world of the Grand Tour, Neptune. Behind it, Uranus shrank into a faint, pale blue dot, hanging alone in the cold dark. Though it had only passed by once, Voyager 2 forever changed how humanity saw the planet. The journey continued once more. The silence, the cold, the tranquility of Uranus gave way to a new anticipation. For ahead lay another world, deep blue and tempestuous, like an ocean suspended in the sky. But that is the story of the next chapter, when Voyager 2 makes its historic approach to the last planet of its grand tour. When Voyager 2 drifted away from the faint halo of Uranus, that pale blue world slowly shrank into a dim speck floating in the darkness. And from within that very stillness, a deeper, richer blue, like an endless ocean of the sky, began to rise in the distance. It was the final destination of its grand planetary journey, Neptune, where Voyager 2 would close the chapter of the Grand Tour with a meeting both radiant and gentle. After Uranus, Voyager 2 adjusted its trajectory toward Neptune, the eighth planet and the farthest world on its list of assigned encounters. In August 1989, after more than 12 years traveling through cold, lonely space, Voyager 2 entered Neptune's gravitational realm. This is the final step in the planetary journey, a once-in-a-lifetime encounter with the deep blue world at the edge of the solar system. It was more than a scientific milestone. It was the whisper of a dream that had lasted over a decade. Through Voyager's eyes, Neptune appeared like a dark turquoise gem placed against the cosmic night. Its blue was deeper and more vivid than Uranus's, as though Neptune carried within it a vast ocean forever hidden from sight. Methane in its atmosphere absorbed red light, leaving behind a cold yet luminous blue. Above it, thin white clouds of methane drifted lazily, tracing soft streaks across the planet's dark canvas. But most striking of all was the storm Voyager 2 discovered, the Great Dark Spot. Against Neptune's deep blue backdrop, Voyager saw a vast dark oval, a massive storm system reminiscent of Jupiter's Great Red Spot. Around this dark region, white clouds raced past, revealing winds faster than anywhere else, the fastest in the entire solar system, reaching up to 2,000 km/h. The winds were so swift, they seemed to stretch the air into thin, pale ribbons, like strands of white silk dancing around a colossal whirlpool. The whole planet appeared to be performing a silent ballet of wind and cloud, fierce yet strangely soothing when viewed from afar. But if Neptune was the stage, Triton, its largest moon, was the jewel of the performance. As Voyager 2 approached Triton, the first images astonished scientists everywhere. Triton's surface carried a soft pink tint, the result of a layer of frozen nitrogen, frozen methane, and organic compounds spread across its crust. And then came the unexpected. Voyager 2 discovered geysers on this icy moon. Voyager 2 captured an astonishing sight on Triton, fountains of gas and fine dust erupting from the frozen surface, shooting upward for kilometers before being swept sideways by Triton's winds into long, dark streaks. For the first time, we witnessed geological activity on a distant frozen moon like Triton. One might imagine Triton as a world drifting in eternal cold, yet beneath its thick crust of ice, geological life still quietly stirred. Picture yourself standing on Triton, under Neptune's pale violet sky, watching plumes of icy material rise and freeze as they fall like snow, a scene straight out of a dream. These geysers evoked a sense of mystery, as if Triton were a stage for delicate dances of cold vapor, where nature expressed itself through the subtleties of ice and wind. Neptune, like Uranus, had a ring system, though so faint that before Voyager 2 they were only suspected, never seen clearly. Voyager 2 confirmed their existence. Even Neptune possesses its own fragile rings, dim and difficult to see, but Voyager 2 spotted them within the darkness. These rings existed as incomplete arcs at first, like sketches that had not yet closed into full circles. As Voyager 2 drew closer, they connected into delicate bands. Thin, shadowy veils wrapped around the deep blue planet. Voyager 2 also discovered several small moons. Nereid, Proteus, Despina, tiny icy bodies quietly orbiting the great blue giant. They felt like ancient grains of cosmic dust left over from the solar system's earliest days, each holding memories never told. As the data from Neptune and Triton streamed back to Earth, the control room at JPL was filled with emotion. Scientists cried when the final images from Neptune arrived, not from sadness, but from overwhelming pride and awe. 12 years, 4 planets, hundreds of moons, all thanks to a small spacecraft named Voyager 2. It was a moment where science and emotion intertwined, when an unfeeling machine became the bridge carrying humanity to places it had never stood. The Grand Tour had ended in perfect form. From Jupiter to Saturn, from Uranus to Neptune, Voyager 2 became the lone witness of a journey humanity might not repeat for centuries. But even with its mission accomplished, Voyager did not stop. Using Neptune's gravity for a final boost, Voyager 2 leaped out of the last planetary orbit. Now, both Voyager spacecraft are on interstellar paths, leaving the familiar planetary neighborhood behind. And so, after the final glimmer of Neptune faded, Voyager 2 entered a different kind of night, one with no bright planets to greet it, only the vast, waiting darkness of interstellar space. Yet within that darkness, Voyager's greatest story was just beginning. The story of the solar system's edge, where the sun no longer rules, and where the universe beyond begins to speak. As Neptune's deep blue glow slowly faded into the darkness behind Voyager 2, the adventure that had stretched across more than 12 years among the planets gently reached the close of one radiant chapter. And in that very moment, somewhere far above the plane of the ecliptic, Voyager 1, its older sibling, was preparing to carry out a mission no less profound: to look back at the entire solar system as if taking one final breath before stepping fully into the starless interstellar night. That was when the next part of the story began, its most beautiful, quiet, and deeply human chapter. The family portrait of the solar system and the moment Earth appeared as the pale blue dot. After completing its exploration of distant worlds, Voyager 1 was given a task by NASA that was more symbolic than scientific. On February 14, 1990, following a suggestion by astronomer Carl Sagan, NASA commanded Voyager 1 to turn its camera system back toward the place it had come from, its own birthplace. At that time, Voyager 1 was about 6 billion kilometers from the Sun, nearly reaching the edge of Pluto's orbit. Before shutting down its camera, Voyager 1 looked homeward one last time. The idea was simple yet sacred: to let a human-made explorer gaze back at the world that created it, like a thoughtful gesture before stepping into the unknown. When the photographs arrived, one of them became legendary. Earth, just a tiny pale blue speck, less than a single pixel in size, floating in the vast darkness of space. The small dot lay within a shaft of light that had slipped into the camera's lens, making it appear as fragile as a dust mote drifting in the last rays of a sunset. Earth, home to all of us, appeared as nothing more than a faint, lonely dot suspended in the cosmic night. No visible borders, no trace of humanity. Just a small, solitary glimmer amid scattered sunbeams. From 6 billion kilometers away, every city, mountain range, ocean, every story, every sorrow, every joy, everything humanity had ever lived through, collapsed into a tiny speck almost impossible to notice. The image stirred something tender in the human mind. A reminder that we are small, fragile, yet profoundly precious, because Earth is the only place where life is known to exist. With his characteristic sensitivity and wisdom, Carl Sagan wrote words about this image that carried enormous weight. He said that astronomy is an experience that humbles the soul, that no clearer demonstration of humanity's foolish self-importance exists than this distant photograph of our tiny world. Astronomy is a humbling experience. Perhaps there is no better demonstration of the folly of human conceit than this distant image of our tiny world. To me, it underscores our responsibility to treat each other more kindly and to cherish the pale blue dot, the only home we've ever known. Those words, whenever spoken, make listeners pause, not out of sadness, but because they hold a gentle truth. We live on a small blue dust mote in the dark ocean of the universe, and its very smallness makes our home unimaginably precious. After that moment, Voyager 1 shut its camera down forever to conserve energy. There was no longer enough light to capture, and no scenes left that needed to be recorded by human eyes. From here on, both Voyagers would travel entirely through darkness, relying only on instruments for charged particles, plasma waves, and magnetic fields to tell us about the final frontier. From this point on, the two spacecraft journeyed through the endless night, taking no more souvenir pictures, only quietly sensing the universe around them. It was like two aging travelers pressing onward beneath a sky that would never brighten, still faithful to the mission they carried. The pale blue dot photograph was not just a piece of cosmic imagery. It became a gentle reminder that every conflict, every dispute, Every worry in human history has unfolded on a point of light so small it nearly disappears. And because of that, our responsibility is to care for it, to care for each other, to live with kindness, for it is the only home billions of humans across time have ever had. Voyager 1, after looking back, turned once more toward the unknown, heading into a region where sunlight grew so faint that day and night could no longer be distinguished. From this chapter onward, its journey would no longer be about planets, but about the layered boundaries of the solar system, where the sun's influence slowly fades and the space between the stars begins to speak. A new chapter, deeper, quieter, and more mysterious, was opening. And that was when the story reached the final frontier of light, the threshold humanity had been waiting for since 1977, the edge of the heliosphere, the doorway into interstellar space. When the pale blue dot photograph brought Voyager 1's one and only backward glance to a close, the spacecraft no longer had any reason to look behind. From that moment on, both Voyager 1 and Voyager 2 faced forward, toward a realm where there were no more pictures to take, only the invisible flow of particles and cosmic winds to guide their way. It was from that farewell to Earth that the two aging travelers stepped into a new chapter, one where light slowly faded and darkness opened endlessly ahead. This was the moment when both approached the threshold of the solar system, the boundary between the sun's domain and the ocean of stars beyond. A place with no signs, no markers, only subtle hints that only patient wanderers like the Voyagers could recognize. The edge of the solar system isn't a sharp boundary. It's more like a vast buffer zone where the sun's power gradually weakens and gives way to the influence of the galaxy. Scientists call this region the heliosphere, a giant bubble blown by the solar wind surrounding all the planets. Imagine the sun as someone blowing a bubble. The heliosphere is that great bubble of solar wind wrapped around us, and the Voyagers are drifting toward the inside wall of that bubble, preparing to slip through it into the ocean between the stars. It's a gentle image, easy to grasp, one that helps listeners feel the soft immensity of space. After 1990, with no more planets left to visit, Voyager 1 and Voyager 2 had only one task: to fly. To fly in silence, to fly in darkness, to fly through a nearly empty void. Throughout the 1990s and 2000s, Voyager 1 and 2 simply continued onward in quiet. Every so often, they detected the solar wind weakening, while the density of cosmic rays from the galaxy increased, signs that they were nearing the boundary. These shifts were like the scent of the ocean when a ship nears shore, or the distant sound of waves when a traveler senses the sea ahead. The first boundary Voyager 1 encountered was the termination shock, the solar wind's shock front. This is where the sun's particles, speeding outward at supersonic velocities, suddenly slow when they collide with the denser environment near the edge. No complex physics is needed to imagine it. It's a shockwave in space, an inner boundary of the heliosphere. When Voyager 1 crossed it in 2004, its instruments recorded plasma temperatures rising sharply, the solar wind slowing, and the surrounding space growing denser. Voyager 2 felt the same shock a few years later, a soft knock at the door, signaling that more boundaries lay ahead, but none too far now. Through the late 2000s, the science teams watched every signal the Voyagers sent. They monitored solar particles, measured cosmic rays, and waited for unmistakable changes. Years passed, full of both patience and longing. Ed Stone, the soul of the Voyager project, once joked, "The question, 'Are we there yet?' is finally about to have an answer." His words made the team smile, simple but containing decades of human anticipation. Voyager 1 kept flying steadily, and everyone followed its heartbeat through the data it sent home each day. And gradually, the signs sharpened. Solar particles fell year after year, while cosmic rays from the galaxy surged. Then came a particular day. Data revealed that particles from the sun had dropped to almost zero, while cosmic rays spiked to unprecedented levels. That was the moment scientists knew Voyager 1 had reached the inner wall of the bubble, just steps away from crossing the final boundary. The journey toward the heliopause, the outermost boundary of the heliosphere, was not dramatic like an explosion, but gentle, almost serene. You might picture it like a small boat passing through the last line of waves as it leaves a quiet bay for the open sea. Inside the bubble, the solar wind held Voyager like warm water against a hull. Outside, the stellar ocean waited, carrying particles born from ancient supernovae, echoes of billions of years of galactic history. When Voyager entered that realm, it couldn't see the change, but felt it through every particle that touched its instruments. Both Voyagers were moving toward this final border, but Voyager 1 was the first to reach it. After more than 30 years of flight, it was preparing to place the first robotic footprint into interstellar space. What lay ahead held no images, no colors, yet it carried more meaning than any planetary photograph. It was living proof that human technology, human curiosity, and human persistence could reach farther than anyone had once dared to imagine. For the listener, imagining this journey feels like watching a tiny boat drift slowly out of a sheltered inlet and into the vast open ocean. There is no soundtrack, no glow of light, only the perfect stillness of a place untouched by any traveler before. And that is the beauty of Chapter 14, the chapter that tells of the moment Voyager stood at the doorway of the galaxy, where an entirely new story for humanity was about to begin. As Voyager 1 quietly approached the final inner wall of the heliospheric bubble, every signal it sent home felt like a slow, deliberate tap, each one hinting that the boundary was beginning to emerge. And then, from within the silence that had wrapped the little spacecraft for decades, something unusual began to take shape, as though the entire journey since 1977 had been quietly leading to this single point. In that soundless transition, Voyager 1 prepared to leave the sun's gentle, sheltered sea and drift into the vast ocean of the galaxy. This was the beginning of Chapter 15, the moment of crossing, the instant Voyager 1 officially entered interstellar space. August 25, 2012 became a landmark day, although for many months afterward, no one dared to claim anything with certainty. At that time, Voyager 1 was about 121 astronomical units from the Sun, roughly 18 billion kilometers. On that day, Voyager 1 was at 121 AU from the Sun. Suddenly, its instruments detected that solar particles had nearly vanished, while cosmic rays from beyond doubled. After a decade of hovering near the bubble's edge, the moment had finally arrived. Voyager 1 had stepped into interstellar space. There was no explosion, no dramatic flash, only the shift of numbers, lines on graphs, but those lines wrote an entirely new chapter in human history. The Voyager team, having watched over the spacecraft for more than 3 decades, was filled with joy, but maintained their usual caution. It wasn't until September 2013, after analyzing thousands of data files, that NASA officially announced that Voyager 1 had crossed the heliopause. During the press conference, project leader Ed Stone quietly delivered a sentence that later became iconic. With the new and key data, we believe this is humanity's historic leap into interstellar space. The statement was both solemn and gentle, like a modest footnote in humanity's book on the cosmic age. A remarkable twist of luck helped confirm the milestone. Voyager 1's plasma instrument had been broken for years, so it could no longer directly measure plasma density around it. But in 2012, a major solar eruption, a CME, left the Sun and took more than a year to reach the spacecraft. When the cloud of solar material from that flare reached Voyager 1 in April 2013, it caused the plasma around the spacecraft to vibrate like a violin string. The frequency of the vibration revealed that the plasma density was 40 times higher than inside the heliosphere, the signature of cold, dense interstellar space. That discovery felt like an unexpected gift from the Sun, as if the star itself had plucked a soft note to tell Earth exactly where Voyager was. The team's reaction was warm and full of emotion. Plasma researcher Don Gurnett exclaimed, "We practically jumped out of our chairs when we saw the oscillations. It showed the spacecraft had entered an entirely new region, just as predicted for interstellar space, totally different from inside the Sun's bubble. Clearly, we had crossed the heliopause." Hearing the story, one can almost sense gentle smiles spreading across the room. Not loud, not triumphant, but the quiet joy of people who had waited so long and so patiently that even their celebration felt tender. From that moment onward, Voyager 1 occupied a place unlike any spacecraft before it. At that time, Voyager 1 was about 18 billion kilometers away, its radio signal taking more than 17 hours to reach Earth. The little craft had flown far beyond the Sun's protective embrace. Outside the heliosphere, it was like a message in a bottle drifting across the galaxy's ocean. It's a soft image, a glass bottle carrying a letter, the Voyager golden record, floating gently through a river of stars. Gravitationally, Voyager 1 still belongs to the solar system, for it has not yet escaped the vast Oort cloud. But in terms of physical environment, it is now in interstellar space. In this new realm, the solar wind no longer rules. Instead, the breath of millions of other stars prevails. Without the Sun's bubble to shield it, Voyager 1 now sails in the shared cosmic current, where every particle and every cosmic ray carries a fragment of the galaxy's story. Voyager 1's crossing of the heliopause was not just a scientific achievement. It was symbolic, much like the first human steps on the moon. Smaller, quieter, without applause or flags, yet perhaps deeper in its philosophical meaning. For the first time, a human-made object had left the Sun's domain and entered a region where the Sun is just one among hundreds of billions of stars. Voyager 1 became the first artificial object to reach interstellar space, a tiny sail drifting into the universe's great open sea. The story is not only about science, but about the enduring hunger to explore. And as a soft closing thought for this chapter, from now on, Voyager 1 will tell us the story of a realm humanity has never known, the space between the stars. In the stillness of interstellar space, Voyager 1 continues whispering home, signal by signal, like the steady footsteps of a traveler crossing a horizonless ocean. And that journey, no matter how far it goes, remains our story too, the story of the people who sent it forth, believing that the universe is vast enough to welcome humanity's endless curiosity. After Voyager 1 crossed the heliopause and offered humanity the first echoes from interstellar space, all eyes naturally turned to the younger sibling, still drifting inside the Sun's great bubble. For years, Voyager 2 pushed steadily through the thinning plasma at the edge, following the trail its older brother had traced, as though preparing for a quiet reunion somewhere beyond, where the solar wind no longer offered shelter. And then, in a way both gentle and quietly sacred, Voyager 2 became the second representative of humankind, to slip into the wide, starlit sea. This marked the beginning of Chapter 16, the story of Voyager 2 crossing the gateway of the heliosphere and entering interstellar space. In late 2018, Voyager 2 began detecting familiar signs. Low-energy particles from the Sun dropped sharply, while galactic cosmic rays surged. It was the same pattern scientists had seen with Voyager 1, and everyone understood what it meant. The final doorway was waiting just ahead. As predicted, on November 5, 2018, Voyager 2 crossed the heliopause and entered interstellar space. More than 6 years after its elder sibling, Voyager 2 followed it out of the heliospheric bubble. Despite launching 16 days earlier than Voyager 1, its detours to Uranus and Neptune delayed its escape into interstellar space. But at last, it too crossed the boundary, becoming the second human-made object to plunge into the star ocean. In that moment, the science team celebrated not just another spacecraft reaching interstellar space, but the fact that Voyager 2 carried instruments Voyager 1 had lost long ago. This turned Voyager 2 into a fully equipped explorer, providing a richer picture of the interstellar plasma. Voyager 2 confirmed that what Voyager 1 observed wasn't a fluke. It measured the plasma beyond the heliosphere as much colder and far denser than inside. The numbers alone proved the spacecraft had truly left the bubble. Inside the Sun's domain, the plasma is hot and thin. Outside, it is cold and dense. Everything matched the models. Only now, the models had solid data behind them. The fact that the two spacecraft crossed the heliopause at different locations added another layer of intrigue. Voyager 1 exited toward the north of the heliosphere, while Voyager 2 traveled closer to the ecliptic plane. Yet both crossed at nearly the same distance, about 120 AU. Researcher Bill Kurth once noted, "This suggests the heliosphere is almost symmetrical, at least at the 2 points where the Voyagers crossed. It means both locations sit nearly the same distance from the Sun." In the end, the Sun's bubble seemed rounder and more balanced than many previous models had predicted. Another surprise left scientists stunned. The magnetic field direction beyond the boundary was almost parallel to the field inside. Voyager 1 had seen this before, but many assumed it might be a strange coincidence. Voyager 2's magnetometer showed that the interstellar magnetic field aligns in nearly the same direction as the one inside the heliosphere, matching Voyager 1's result. This meant the fields didn't meet in a sharp break, as expected, but in a smooth transition. The discovery shook expectations. The heliopause wasn't a rigid wall, but a gentle blending between two environments. The heliosphere also wasn't as sealed as many models had imagined. Thanks to its still-functioning instruments, Voyager 2 detected a small leakage, some solar particles seeping outward, and some interstellar particles drifting inward. NASA once compared it to this. If the heliosphere were a spacecraft sailing through interstellar space, it seems the hull leaks a little, especially near the region where Voyager 2 crossed. It's an image that softens the idea of the boundary, making it feel more like a thin membrane where matter can drift back and forth. Although this second crossing lacked the dramatic shock of Voyager 1's first passage, joy and pride still spread through the scientific community in 2018. When the confirming signals arrived, scientists bowed their heads to the achievement of both aging spacecraft. There is still so much to learn about the space just beyond the heliopause, Ed Stone said. Thanks to Voyager 2, we know now that what Voyager 1 saw was not just a special case. Voyager 2's data both confirmed and deepened the mysteries, illuminating a research frontier that will last for decades. Now, both Voyager 1 and Voyager 2 drift outside the Sun's bubble. Separated by billions of kilometers, they are, ironically, closer to each other than to their home world, simply because they both float through the same cold interstellar sea. The feeling is like imagining two siblings from different rivers finally meeting out in the same open ocean, quietly accompanying one another, though they will never see each other. Two tiny points in an immense space, yet two patient voices humanity has sent into the universe. With both Voyagers now beyond the boundary, the story does not end. It unfolds into a new promise. The signals they send back from interstellar space will illuminate the true structure of the galactic environment around us. And at that very edge, the next chapters await. Chapters about the future, the legacy, and the enduring meaning of these two small, steadfast spacecraft. When Voyager 2 finally joined its older sibling in interstellar space, the picture of the world beyond the sun's bubble began to grow fuller, richer. One spacecraft had given us the first lone note of a cosmic symphony. The other added clarity to its melody. Thanks to both, stories from the star ocean began to surface slowly, like waves of faint light rippling across the cold dark. And this is where Chapter 17 begins, the place where Voyager tells us what it is seeing, hearing, and feeling in the boundless interstellar expanse. Once outside the heliosphere, both Voyagers became humanity's first messengers to send back real data from a region we had only understood through theory. Their information did not arrive in bursts or shouts, but in small, steady drops, each one falling into the pool of human knowledge, patient and precious. One of the most significant findings came from Voyager 1, which helped us understand the protective role of the heliosphere. Beyond it, the flux of galactic cosmic rays was far higher than within. Data from the spacecraft showed that the giant bubble blown by the sun shields us from more than 70% of dangerous cosmic radiation. The sun acts like a mother shielding her children with her arms, keeping Earth and the inner planets safe from much of the galaxy's radiation. It's an image easy to feel. We live within a warm, protective embrace, even if that embrace is only a cloud of countless tiny charged particles. Outside the sun's bubble, Voyager stepped from a thin corridor into a denser space. Both Voyager 1 and Voyager 2 confirmed that the plasma beyond is dozens of times denser than inside, yet far colder. Inside the heliosphere, the solar wind can reach hundreds of thousands of degrees. Outside, interstellar plasma is only about 30,000 K. Outside is colder and denser, inside is hotter and thinner, exactly as predicted, and Voyager has confirmed it. The shift feels like stepping from a warm room into a quiet winter night, distinct but natural. Because the two spacecraft crossed the boundary at different spots, scientists were able to map the heliosphere's shape more accurately. Voyager 1 crossed at about 122 AU, Voyager 2 at about 119 AU. A difference of only a few AU suggested that the sun's bubble is more symmetrical than many models once proposed. Scientists often compare this to two explorers touching different parts of an elephant, each sensing only a portion, but together giving us the outline of the whole creature. Thanks to the Voyagers, the shape of the heliospheric elephant has become clearer than ever. A surprising discovery left researchers stunned. The magnetic field direction beyond the boundary was almost parallel to the field inside. Voyager 1 had noticed this, but only after Voyager 2 confirmed it did the scientific community accept that it wasn't a coincidence. It appears that the sun's magnetic field doesn't end abruptly, but blends gently into the interstellar magnetic field, forming a continuous band. Rather than a hard wall, the boundary becomes a soft mist where properties merge. Voyager 2 also revealed that the heliosphere leaks. Some particles from inside drift outward, and some from outside seep in. NASA once explained it this way. If the heliosphere were a ship sailing the cosmic ocean, its hull would have a few tiny cracks, letting a little seawater leak in and a little leak out. The image helps us imagine the sun's boundary not as a sealed barrier, but as a living, breathing membrane. Beyond numbers, the Voyagers also returned unique sounds. Not sounds as we know them, but plasma oscillations converted into audible frequencies. When Voyager 1 crossed the heliopause, the surrounding plasma vibrated, rising in pitch. In the data Voyager sent back, once translated, we could hear a low hum climbing upward, the song of plasma as the spacecraft moved from one environment to another. The sound feels like a gentle greeting from the cosmos to its first visiting guest. By 2025, Voyager 1 is about 23 billion kilometers away, and Voyager 2 about 19 billion kilometers out. Each day, they drift another 1.4 million kilometers farther from the Sun. Signals from Voyager 1 take about 21 hours to reach Earth. Voyager 2's take about 18. With each passing year, the distance grows by hundreds of millions of kilometers. They are becoming lonely artificial stars wandering the Milky Way. Lonely, yes, but still breathing, sending tiny whispers home like two elderly companions speaking softly across a vast ocean. Their energy, however, grows scarce. Both spacecraft run on decaying nuclear power sources that lose several watts each year. Now they operate at around 50 watts, barely enough for a small light bulb. By around 2030, instruments may begin shutting down. This realization brings a soft, wistful sadness, like a bead of dew, because everyone knows that even when the Voyagers fall silent, their journey will continue forever in the cosmic night. Communication grows more fragile each year. The transmitters on the spacecraft output only about 23 watts, but by the time signals reach Earth, they have weakened by a factor of 1 billion. Only NASA's giant deep space network antennas can detect such faint whispers. Each message is like a letter, taking more than 18 hours to reach Voyager, and the same to return. Slow as it is, the conversation between Earth and the Voyagers hasn't ended. Like two old friends murmuring to each other from opposite sides of an ocean. Despite their age, the Voyagers never stop surprising us. Ed Stone once said, "Voyager keeps surprising us with new discoveries, and to this day, it remains true. One might assume interstellar space has nothing left to reveal, but every year, the little spacecraft teach us something new." To close this chapter, we are still listening to Voyager every day, waiting to hear what else they can tell us about the interstellar sea, until their voices fade for good. And from that quiet moment of listening, the story gently turns toward its final part, toward meaning, legacy, and the endless journey these two robotic travelers will leave behind for humankind. When the stories from the interstellar ocean drifted back from the Voyagers in the previous chapter, listeners began to sense that the data they carried were more than just knowledge. They were messages whispered from a distant world. And from those messages, our minds opened into a wider space, a place where we could reflect on ourselves, on our home, and on the meaning of humanity's long journey. That is where the final chapter begins, soft as a breath in a quiet night. The chapter about Voyager's legacy and the reflections it leaves beneath the starry sky. Now, with both Voyager spacecraft tens of billions of kilometers away from us, Earth, seen from their vantage point, has faded into nothing more than a tiny spark swallowed by the star ocean. No borders remain, no cities, no people distinguishable. Everything we are is contained within one faint, fragile dot hanging in an endless darkness. That image reminds us of humility, that no matter how advanced our civilization becomes, we remain just a small fleck on the vast canvas of the cosmos. Carl Sagan once said that the photograph was a gentle reminder of our smallness and our compassion, that when we see ourselves reduced to a pale whisper of light, our quarrels suddenly shrink, and kindness finds space to bloom. Voyager's scientific legacy stretches out like an epic. It opened new chapters of planetary science, the fierce volcanic eruptions on Io, the fractured lines hinting at a hidden ocean beneath Europa, the delicate rings of Saturn, the deep blue storms of Neptune, the icy geysers of Triton, and the existence of an invisible boundary where the solar wind dissolves into interstellar plasma. Every image, every measurement, every number Voyager returned forced textbooks to be rewritten. Across decades, the little spacecraft quietly became one of the greatest teachers in modern astronomy. But Voyager's legacy is not solely scientific. It touched people in a different way, subtle, human, deeply emotional. Millions on Earth grew up reading about the two small spacecraft drifting through unseen regions of darkness. They imagined themselves traveling alongside Voyager, watching giant planets sweep past, feeling a strange hope rise for worlds humanity had never touched. Voyager became a symbol of curiosity, of the longing to reach beyond limits, not only in science but in the human spirit. And in the eternal dark of interstellar space, each Voyager still carries a small treasure, the golden record. On it lie the gentle sounds of Earth, the hush of ocean waves, the laughter of children, the pulse of a human heart. Greetings in 55 languages and pieces of music that can soften any listener's chest. The golden record is like a love letter humanity sent to someone unnamed, someone we do not know and may never meet. Hello from the children of planet Earth. We wish you peace. A simple message, yet containing all the hope that we are not alone. Even knowing no one may ever find the Voyagers, we sent it anyway. Because reaching outward is part of who we are. What makes the Voyager story even more extraordinary is the knowledge that the spacecraft will outlast Earth itself. As Bill Kurth once remarked, the two Voyager probes will outlive Earth. They will continue to orbit the Milky Way for 5 billion years or more. Imagine a day when the sun fades, the Earth cools or is consumed, yet these two small craft still wander through the galaxy's spiral arms, carrying memories of a world that once shone brightly. They will become drifting relics of human civilization, grains of intelligent dust wandering the star ocean. And perhaps, in some far future, millions or billions of years from now, another intelligence, or perhaps our own distant descendants, will stumble across Voyager. They will recognize it not as a stone or a natural fragment, but as an artifact crafted by an ancient civilization. Maybe they will lift it gently, brush off the interstellar dust, and open the golden record. In that moment, the sounds of old Earth will play within an alien world. The rush of water, the beat of a heart, a voice saying, "Welcome." A meeting needing no explanation, where past and future touch in silence. It is an image soft as a dream, but full of hope. A beautifully open ending that lets the imagination wander. From Voyager's story, we understand that even in our smallness, humanity carries an infinite longing. We sent into the cosmos a spacecraft no bigger than a small car, yet inside it lives the vision of billions of minds. The universe is vast and cold, but humanity's desire to explore is no less vast. Voyager reminds us that every step of science is also a step toward understanding ourselves. And as a gentle lullaby, the final lines may whisper, as you drift into sleep tonight, somewhere at the edge of the solar system, two tiny artificial lights continue their quiet journey. In the silence of space, our story is still being told. Voyager is humming to you through its own voyage, a lullaby about the vastness of the cosmos and the small, wondrous home we call Earth. May you dream sweetly among the stars. And then, in the remaining quiet, the listener feels a calm settle in, like someone returning from a long, gentle adventure, peaceful, reflective, and full of meaning.